Hello and welcome to the Backyard Machine Shop. Well, in the last video in the Pratt Whitney Lathe, I started taking apart this quick change gearbox. Well, when I first looked at it, it looked like it was going to be a really quick, simple job, to take it apart. Well, it turned into about a 5-hour job. So I didn't capture a lot of the video, a lot of the taking it apart on video, simply because it was a lot of time for me to figure out how to get it apart. I ended up using probably 3 different pullers, and I ended up having to make 1 or 2 so to get it all apart. But it really wasn't that hard to take apart. It was just me figuring out how to do it and then having to make the tools to do it with. So what I'm going to do right now is I'm going to give you a little demonstration of how it was put together, and really in the end you'll see how simple this thing is built, and I guess that's what makes it really good. But so here's what we had. In the last video, one of the things we were looking at was this sleeve right here. And what this sleeve does is this is part of your gear selector on your quick change. Inside this sleeve we had this gear. Okay? And the way this gear worked was this housing here, y'all remember, it fit inside there, and this was your selector, and it slid across the top of this shaft. And inside of that housing we had, let me get this up here because I just want to tip back on it like that. We had this pinion gear, and this pinion gear rode along this shaft here, and then it allowed you to make your selection of gears. Okay, so one of the things we were looking at was how to get this thing out of the housing. Well, it's kind of, I ain't gonna say embarrassing, but as simple as it was, it took a minute to figure out. If you remember, we had pulled this sleeve out of this side. It was one of the first things we did. Okay. All right. So this is one of the first things we did. We pulled that sleeve out of that side. Let me move a couple of these things around, and we'll just put it together right here. All right, and during the video, you saw me take the screws out of this flange. Well, when you look inside, let me turn this around. When you look inside here, this went into this housing right here, okay? And when you look inside here, there's really it doesn't look like anything is there for it to push out. Well, basically, what it does is this bearing surface captures the shaft on this side, okay? And by those 2 pieces being bolted in, capture the whole assembly here. So what happened was, once we had already pulled this one out, okay? Then we had pulled our shaft out. All right. What was left was, we got it sitting in here like this. What was left, you remember we got a piece captured on this side, and then when we pulled this bearing out, this whole assembly just came out the back. So it was really simple in the end. It just took me a little while to figure it out. And so we got that done. Let's find a place to put it. Okay, so we have a bearing housing here and a bearing housing here. Okay, okay guys, after we got the gear assembly apart, the selector assembly, the next assembly was the actual drive gears or the selection gears for the gearbox. So when we had left, I think the last thing we had was we have a set of bearings that go on this shaft. Now this shaft is the actual shaft that goes through the gears. And on this end down here we had this bearing. Okay. So when I left, I think one of the last things I'd done was I'd pulled this bearing out, and I pulled it out with a puller. So I think that was one of the last things that was in the video. and then this bearing set on the other end of the shaft, okay, which fits inside the housing right here. All right, so inside this housing, this shaft was traveling. Well, let's see. It traveled through this gear set right here, like this, and then the gears were in here. And we had, like I said, we had this bearing on this end, and this bearing on this end. Well, one of the things about this shaft is it's a keyed shaft, and the gears are bored and keyed. Well, you had two sets of gears that fit down here, or two gears, along with all the drive gears that went inside in this housing. So for instance, one of the things you had was, you had this gear here. Let's see if I can get it in there. This gear was in here like that, and it had a bearing on its outer surface right here. Okay. Inside that gear, and on this shaft, you had these two gears, and these two gears drove a change gear that had already been taken out from up here. Well, anyway, this shaft is 1 inch on this end, and so you had a couple of gears that fit on this end of the shaft, and then you travel a few gears down, you had another set of gears that fit up on that part of the shaft. Well, here's where a lot of the problem was. These gears were a slight press fit onto this shaft. So when I worked them off, when I had to get them off, you had to work them a little bit, pull the shaft, work them a little bit, and you had to do that times 12 to get all these gears. Now once you got the shaft beyond that point, then you can start dropping the gears off. I'm not sure how they're going to go back together, because they're going to have to be pressed on, and they're going to have to be pressed on inside this housing, and it really worries me pressing. And it's a slight press fit, so it's not a real bad one, but still, I don't like pressing on this cast iron in the areas like here. It's not really supported, but that might have to be the way it does. Another option I've thought of is, because you're not going to be able to slide the gear all the way up on the shaft where it belongs, because it'll bottom out up here, and you won't have the shaft available to put the gear on. So you're going to have to place gears on here a little bit at a time and press them to a point, figure out where you can press them to, and then put another gear on and another gear on and another gear on. So it's going to be just about as bad putting it back together as it is taking it apart. Some of the gears are a little tighter than the others. We're going to measure them in a few minutes. I'm going to do a little inspection on everything, and we'll see what kind of fit we had. Okay, so that came in, and that's kind of where I left you, as I was working these gears off. And the only thing I wasn't able to get out of here, there's a bushing right here that drives the lead screw, and then these pins. I had broken one of these pins off, and I have it in the bucket over here, but I'd broken it off when I first got the lathe. And I don't know what kind of material they are. They're like a ceramic. So I tried to knock one out the back, and it chipped, and so I just stopped. And so we left that on. Here, let me put this down. I'll turn it around and show you what all we left on. All right, so we left this. We've left this bushing in here. I have tried everything to get it out. I'd made a squeezer to push it out, a pusher. You can't get in here to pull it. I've tried to knock it out with a wood dowel. I can't get it to budge, so I'm going to leave it right in place. It's in good shape. We left the pins, like I said. Now, maybe some of you know what kind of material this is, but it's almost like glass. I say it's some kind of ceramic or something of that nature, maybe some kind of casted hard metal, but they're like glass. They'll chip. Now, if I ain't mistaken, I was able to drill it though when this one was in here because I had to drill it out to get the broken off part. I left the badge on. The badge, now the thing I do with restorations, if I can help it, I don't remove badges, especially badges like this that I don't want to get messed up, because it never fails trying to get all these drive pins out, and you can slot them and try to squeeze them out. That works about half the time. Another thing you can do is try to get up under them and wedge them up. That works about half the time. And the one thing that you can do is break everything, and that can be, if you ain't careful, that could be every 100% of the time. So I left it on here, and what I'll do is I'll tape it up. I want to do some artwork on it and paint it, do some things to it, so I can do that while it's on here. But we'll just tape it up with some painter's tape, and we'll strip the rest of it and paint it. Other than that, maybe this little pin here is still in there. It's all apart. I got all the, I did manage to get all the oil cups out. At first I didn't think I was going to be able to, and I wanted to ask if anybody knows where I can get a good source of the twist type oil cups. I'd be looking for some. It looks like they're quarter NPT. So anyway, here I've got some here. I'll show you what they look like. Here's the oil cups. They twist. They open up. You can oil them. Like I said, I don't know if that's a quarter or pipe threads are kind of foreign to me. That's a quarter or 3/8. I believe it's a quarter NPT though. So that's where we stand with this. So now what we're going to do now is we're going to move the cameras in a little closer, and I'm going to pull some numbers on some of these parts and try to show you where wear is and where there's not any wear. And to be honest with you, I haven't found anything that's worn out, but just to show you on camera that I did check it. So hold on, I'm going to take this off the table, give us some room, and I'm going to move the cameras in a little closer, and we're going to do that. Alright guys, so what I got here is I have, first thing we have is going to be, and I'm not going to measure the bearings in here and stuff inside this housing. There's really no sense in it, so we know that they go in there, and we're just going to leave that alone for right now. But what we are going to do is we're going to take and measure, let's see, the bearings for this shaft, for this end, bearings for this shaft, and the bearing for this end. And there's a couple other things in here we can measure, like that bearing there. And we'll measure, let's say, we'll take a couple of the gears and see what kind of fit we have. We'll take one off of there, and we'll take one off of here. Okay? Maybe we'll take two. Let's take this one right here. Okay? So we'll measure it compared to that shaft. So right now we're going to start with this shaft. And really the only bearing surfaces you had was, on this end you had this fit. Okay? And on that end you had this fit. Okay? And there's an oil passage. I don't know if you can see it, but there's an oil passage down through there. And if I'm not mistaken, this bearing was turned at an angle. So the wear surface is probably going to be here, you know, across here the greatest. So that's what we're trying to measure. And we'll take like 3 readings off each one of these and get it. So tools we're going to use, we have a set of snap gauges, a couple different sizes. And here's one of the things that always drives me crazy. These things are around 1 inch, and the way snap gauges are made, you're at its limit at 1 inch. So, because all the way out, this one measures. Let's get some glasses on. Measures like 1 inch to guess it's 1.25 inches where it's all the way out. Yep, 1 inch, 1.25 inches. And that's what some of these are, is 1.25 inches. And these will not close up enough to fit inside an 1.25 inches. Alright, so I got a piece of paper here. And we're going to write these measurements down because I'll forget them. Alright guys, so I got a piece of paper. Pen writes, let's make sure we're in frame. Okay. Alright, so what we're going to do is we're going to start with this shaft right here since we already have it in the V-blocks. Alright, so we know that this bearing surface here, it mates with this one. So the first thing we're going to do is we're going to come in here and there we go. It does fit in there. Alright, so we're going to drop this down, and we're going down about 1 inch or so, and we'll pull measurements in a couple places. So we pulled our measurement, and we'll get our reading. Alright, so right here, we're at 1 inch, 52 and 3/10. So our first measurement is 1 inch, 252 3/10. Okay. So let's try it again. We'll try it again in the same spot. And I'm measuring across what I would think it would be the highest wear point. Alright, so this time we get 1 inch, 252 and 1/10. So I'm going to go with the 252 and 3/10. Okay, so we'll turn it 180 degrees and we'll measure, we'll turn it 90 degrees and we'll measure the other direction here. Alright, so right there we have 1 inch, 251 and 5/10. So 1 inch, 0.251 and 5. Alright, let's measure that again. The same place, go a little deeper. One inch, 251 and 4/10. So my second measurement is 1/10 off. Okay, and this one was 1 inch, 2521. Alright, so I've measured it 4 times and I've measured it in 90 degree or 100, I don't know how you'd say that, I guess 90 degrees to each other. And so I got 2 dimensions on the shaft. Alright, so our next step, and this is, we'll call this gear, shaft, bearing, okay, and side 1. So we'll mark this side 1. Alright, so now what we need to do is we need to measure the shaft and we'll see what our clearances are. Alright, so what I'm getting right here is 1 inch, 250, that ratchet's a little bit loose on that thing. Here we go. Alright, so we're here, we're getting 1 inch, 249 and 2/10. So measurement A would be 1.249 and 2/10. Okay. Okay, 1 inch, 249 and 3/10. So 1.249 and 3. Alright, so that's our shaft. All right, so we have, break out a calculator. All right, so we have at our shaft. Like I said, we measured our shaft in our bearing in two locations. So we'll take the greatest one, which would be 1 inch 252.3. So 1.2523 minus 1 inch 0.2493 equals to 3/1000 clearance at the greatest dimension. 51,249. That can't be right. Hold on. 1.2523 minus 1.2493. Yeah, 3/1000. So we got 3/1000 clearance in this bearing. And from what I can gather, on this size shaft, the speed that this shaft's turning, you want between 2,000 and 4,000. So I think we're in good shape there. All right, so we got this side measured. What we're going to do is we're going to switch shafts, flip the shaft over, and we'll measure the other end. So on this end, we're good. All right, so let's flip the shaft around. Here's our bearing. All right. So that was A, side A. Okay. Side B. Let's do the same thing. We'll take our bearing. We'll measure it and we'll turn it 90 degrees and we'll measure it again. So I think this is the one that I can't, yeah. All right, so we got to use the smaller bore gauge on it. All right, so here we're going to measure all right, so we're right there. We're at 1 inch, 125 thousandths. Dead money. Let's see. Yep, dead money. 1.125. Okay, let's measure it again. As y'all can see, I don't really trust my measuring with bore snap gauges. I always double check. Dead nuts, 1 inch 125. So we're going to rotate. Let's see here. We need to be right here. Like I said, we're measuring down in there about an inch. All right, so here we are 1 inch 126 and 3/10. Okay, so on side B, 1 inch 126.3, and that's a 0. Let's measure it one more time. Some kicks. All right, 1 inch 125 and 6/10. So 1.1256, 125 and 0. Okay, so we got a little bit more clearance in that side than we do the other way. All right, so let's measure our shaft. All right, our shaft's measuring, on here we measured 1 inch, 1/24 and 2/10. So the shaft is 1.124 and 2. And if you want to see that, let's see. I don't know if you can bring it in and see that or not. Two-tenths. All right, so let's check it again and down a little further. All right, 1 inch, 1/24 and 1/10. Okay, 0.1241. All right, so we'll subtract these two numbers. So we get our greatest number, which would be the 1 inch, 126, 3. I don't think that number's right. Got 5, 6, and 6, 3. I'm going to measure that one more time. All right, 1 inch, 125. And 6/10. So that's what I'm going to go to. 125 and 6. I'm going to scratch that out. All right. So we take 125, 1.1256 minus 1.1242 equals to 1.5 thousandths clearance on this bearing, and that fit. Sorry, I gotta go this way. That fit is about probably right. There's no rocker at all in there. Okay. So bottom line is we have 0.0014 on this shaft, and on this shaft we had 0.003. So we have 3 thousandths on this side of clearance, and we're 1.5 thousandths on this side. So I'm going to call that shaft and them bearings in good shape, and that's the same thing that I'm seeing in the rest of this lathe. Okay. So now what we'll do is we'll move this shaft over, get it out of our way, and we'll put this shaft in. All right. So this shaft here, bearings, get them out of the way, or I won't get them confused. On this end of this shaft, we have this large bearing. Okay. And on this end of the shaft, we have this little small bearing. See, there's a little rock in there, so I plan on seeing a little bit of clearance issues there. All right, so we'll start checking these. Let's get our piece of paper and we'll turn it over. All right, down here we have on this bearing, and I'm going to have to break out the 1 inch. That's what that is, a 1 inch shaft. All right, on this bearing here we have 1 inch and 2 7/10. All right, so we have 1.0027. Okay. And check it again, like I said, check it 90 degrees. All right, 1 inch, 1, 19. All right, so we're at 1.0019, and let's check the shaft. Now the shaft's going to be a 1-inch shaft or smaller. All right, so right there we're at 998 and 998.8. So we're shaft size will be 0.9998. All right, so let's check it again. We'll go a little further down. All right, here we are. I'm sorry, we were 9898, not 999898. And here we were 98. 989. So 0.98. 98. I'm sorry, I'm writing it wrong. That's what I'm doing. 0.09. One. Now I scratch it off. 0.98. Get 75, and so it'll be 9999. 989. All right, and I had it right. 0.9898. All right, so 0.9998. 0.98. $9.99. 75 plus 24. Yeah, 0.9898. No, sorry, that ain't right. Hold on a minute, guys. I'll figure this out. I'm just reading it wrong. I think I got the number. This is so close to 1 inch that I'm... All right, so we're... Oh, that's right, 1 inch. There we go. All right, so we're at 998 and 9/10. That's what we got. 0.998 and 9/10. I knew I'd get it. And second reading is, let's read it up here. Well, no, it needs to be in this area. And the second reading would be 998 and 7/10. So 0.998 and 7. All right, so our clearances here will be 1.0027 minus 0.9987 equals to 4,000. So we had 4,000 clearance on this end of the shaft. So 0.004.
Thank you for sticking with me with that. So we're going to rotate the shaft around. And select another area. Alright, so pop these back open. Alright, on this shaft here, this bearing we're reading 1 inch, 2 thousandths, and 9/10. So I'm sorry, 1 inch, 1 thousandths, and 9/10. So here we got 1.0019. Okay, turn it 90 degrees. All right. And we got same thing. 1 inch, 0.0019. I'll check it one more time just for my curiosity. And, yep, same thing. All right. So let's do our shaft. Shaft's going to be around the 1 inch mark. Okay, our shaft is $9.99. $9.99 and 1/10. Okay, 0.9991. Yep. Check it up here. Here we're reading 9.99 and 9.99 and 2/10. 0.9992. And you can see that. Okay. Alright guys, so again we check this shaft. We're at 9.99.2. Let's do the math. 1.0019 minus 0.9991 equals to 2 thousandths 8 tenths. So 0.0028. Okay, so we got that much clearance on the bearings. All right, so what we want to check now is I want to check a couple of these gears, and let's see what kind of fit we have here. So I've got one of the gears that's up front. Stick the bore in here. There we go, right here. Alright, so we're at 1 inch 250 dead on the money. Alright, let's check it again in another direction. Alright, I got 1 inch 250 and 7/10 on that one. So let's check it one more time. One inch 250 and 3/10. So let's go with the 1 inch 250 and 3/10. So we have 1 inch point 1.2503. Okay, and to bore this this shaft, and this gear will go in this end, so I'm going to check it up at this end. All right, 1 inch, 249, 49 and 9. Okay, so we're at 1.2499. Check one more time. 1.249 and 9. So this shaft to the gear is 1.253. Clear that. 1.2503 minus 1.2499. $1.2503 minus 1.2499 equals to 4/10. So we got about a 1/2 thousandth clearance in there. Okay, so I'm going to check. I checked that gear. We know what the shaft is. I'm going to check a couple more gears here. And all right, guys. So there you have it. My battery went dead, and I don't know how much video we're going to be short as far as the audio, because that's where it went dead on the audio. I can read back off the numbers to you. It went down sometime in this area. Basically, the shaft for the gear set, we had, let's see, 4 thousandths clearance on this end and 4 thousandths clearance on this end in the bearing. Okay, the gear to shaft clearance, we had 4/10. So there's 4/10 clearance, so they should slide on. And that was kind of rough getting them off. So maybe we'll get lucky and it'll just slide back together. The gear shaft, the drive gear that drives the gears, this end here we had 1.5 thousandths clearance, and this end we had 3 thousandths clearance. Everything still fits in like the rest of the lathe. The lathe is either hadn't been used very much or was really well taken care of. So, I mean, to have a lathe that's 100 years old, that all of these bearing fits are this close, like it's still brand new, leads me to believe that it wasn't used very much. So, and with that said, and it's getting late, I think that's going to do it for the quick change gearbox episode 2. Okay, so for the backyard machine shop,